project of other possible textile machine that I have already developed at a very laboratory scale. But the results were very interesting, and those machines could be developed at an industrial scale, and we increase the range of the composite material application by avoiding to use any metallic part linked to a composite part. The first type of machine is named 4.5D, make multi-layer panels. The second one consists in a stitching machine, and that machine is able to plant or left carbon fiber. Its name is OTS, one-side straight stitching machine. I have also developed a double needle stitching machine. In that machine, you can link layers of fiber from only one face, but you can also create from that kind of apparatus a machine for making a special 6D thick fabric, or also a sandwich structure by putting a foam inside the layers. The braiding machine is a COBRACOMP research project, and also I am now developing rotating weaving machine that deposit at high speed on central mandrel, a 3-direction multi-layer high quality armature. Maybe it could be the future of braiding will be that kind of weaving machine, but mainly for more simple parts than by braiding machine. Well, the second view, please.
Okay, it's gone.
My career, I think all the people know me. I have a very long career in developing a lot of very, very special braid machine for making rockets parts. Those rockets are carrying nuclear bomb on top. So I don't speak about those type of machine, but only of machine with very industrial application. For making 4.5D panel, I use a 4-axis numerically controlled machine. The layers are put thread with 6 pipes that is round pins on a frame which has a peripheral. After the first, when you have put the layer that you want, and you can make, and I have made parts with 125 layers, 0, 90, minus 45, plus 45 degree. And after that, you link by a special needle. When you have made panels, you can assemble those panels in a very complex part like this. It's an helicopter gearbox impregnated by a PMI high temperature resin. And for making that part, we have used panels, but because you have a numerically controlled machine, you can make panels with more complexity than simple panels. That is an example of a frame. The frame is, we have made 4 frames in a panel, like big panels with only axial yarn in the central area. So you can deform the panel to have a fuselage frame. To make the helicopter gearbox, can make panels cut it by water jet, and you can arrange that like for a fabric for making an ordinary part, an ordinary rod. The second process is a stacking process or stitching process. It's a real revolution for linking a flange with its skin, because all the test samples have shown an increase in properties, or at least 2 or 3 times compared with the usual way with bonded folded flanges. And it's more simple and more resistant. So the only why that is not a usual way for making composite parts, because there are not such equipment available in serial. You can buy that equipment, and also the know-how also for doing a part with that kind of testing machine. That is an example. That it was for making test sample for an Airbus plane. The stitching machine is on a 7-axis country machine, and the test result was very, very good. And that is now Airbus qualified, and it flies. You by making 4.5D panels, and you assemble the panels by those stitching machine, you can make any kind of brackets in composite material, and you can remove any metallic part linked with the composite structure. I show you satellite bracket. It was for linking a rocket satellite. When a rocket starts, there is a tremendous vibration with a high level of strain on that part, and a composite part made conventionally doesn't work. With that kind of linking, there is no problem of risk of the bonded part is broken by now. It's stronger than any bond. That example also for linking a frame with its fuselage skin. When a plane is going in the upper atmosphere, the pressure inside is bigger than the outside, the air pressure. So you have a deformation of the skin, and with that kind of linking, you are sure that you always have a good linking between all the frame and the fuselage skin. That the stitching machine can be used also to make composite yarns on a full surface, and by piloting that by a computer, you can make very, very special type of parts. A fan jet rotor blade, which is partially made by a stitching machine. So it's a very complex part. So you have a huge possibility when you have a 7-axis country machine and a stitching machine. I have lost my... You can use an apparatus, a stitching machine with 2 cross needles. One we carry the yarn down the bottom part of the layer of yarn. Then that needle go back a little to create a loop in which the other needle go inside that loop. Then the first needle go back, and that put the yarn in the eyes of the second needle, and the two needles are going back on the front layer of yarn. With that, what is interesting, you can create a 6D armature, a 6D fiber architecture, something very different of anything existing today on Earth. And with that, you can link 0 and 90 layers. I composite yarn of 45. And create a 6-direction fiber structure that you can make like the NCF thick fabrics on a easily feasible machinery. And that fabric will have some shapeability because you have not continuous fiber at 45 degrees. And so it's something we can have a huge good. You can also create some rich structure by putting foam inside the layers. Was not being fully developed. I show you some example of 4.5D linked by that kind of apparatus of double needle stitching machine, the back face and the front face. But I show you also an example of a 6D architecture. What is viable on the back face is only the stitched layer and on the back face. It's very interesting to see. And on the front face, because you have loops, it's difficult to see anything. High quality braiding, everybody now wells. So the last part, highlight invention is made with rotary weaving machines that create also like a braiding machine direction architecture, but they are not linked by crossing each one, but by an axial linking yarn. You have 4 nets of yarn, the layer at 45 degrees, the layer at minus 45 degrees, layer of axial straight yarn, and layers of axial linking yarns. All the layers are all the linking yarns are parallel, and so you don't create any void in that fiber architecture. Some example, yarns, a Kevlar sample with a little linking yarns. The linking yarns, you can have a machine 1, 2, 3, or 4 linking yarns. The next prototype I will do will have 2 linking yarns. But the linking yarns can be also big yarns, like, and you can see that on the example of a fabric sample, which are made with 4,800 text glass. And the machine for making that architecture are circular. They are the same architecture general as a braiding machine, but the functioning is completely different. You have rotating shuttles on tracks. You have axial yards, which are put into pipes, and you are also linking yards. We are put on little pipes, very light, able to move very quickly between the shuttle. That is a section view of that kind of machine. In the front view, you can see the linking yard, which are moving between the shuttle, and in the bottom view, you can see the axial yard. We are just pulled by the manual displacement. That are parts made with a great number of parts, rather simple, are not any mechanical difficulty for making that kind of machine. Or rotating the shuttle, you have gear, and you have enough gear to have always a gear in making with the to pull the shuttle. And but my global conclusion, I have shown you interesting processes, but that processes are not used at all, or just at a very little scale. Why? That's my reflection, because it's necessary to separate the work of making composite parts by using machine with the works of making machine and selling them to these companies making composite parts. So I need the help of everybody to find mechanical company that want to develop this machine and to sell them into the entire world. I will be pleased to give you a lot of information and on all those processes. If you send me a requirement for that, of my email, CAHUZAC@gmail.com.